For the next 2 days, you're going to be solving trig problems that you're not given the right triangle and you need to draw the right triangle. Some key vocabulary that you might come across while solving these problems are the terms angle of elevation and or angle of depression. Angles of elevation and depression are always measured from the horizontal. And a very common mistake that occurs with these problems is that people try to draw angles of elevation or angles of depression from a vertical line. Always be very, very careful whenever you're calculating an angle of elevation or an angle of depression, and make sure that you're drawing it from a horizontal line. In the first example here, we're told that a mouse peeking out of his hole in the ground peeks up at an angle of 25 degrees to look at the top of a birdhouse. If the mouse's hole is 20 feet from the pole that holds up the birdhouse, how high is the top of the birdhouse above the ground? And we're asked to round our answer to the nearest tenth. So without a diagram, we have no idea as to which trig function we should use, or even if we should use trigonometry. So when we draw our picture, what I chose to draw here was I chose the ground, and I knew that the mouse was peeking out of a hole in the ground, so I put a point right there to represent where the mouse is located on the ground. And it said that it peeks up at an angle of 25 degrees. So from the horizontal, it looks up at an angle of 25 degrees at the top of a birdhouse. So I knew that somewhere above the ground out there, I needed to have a birdhouse. And then typically a birdhouse is sitting on a pole. So I dropped perpendicular to the ground so that I could create that right triangle. We're asked how high is the top of the birdhouse above the ground. So I called that height from the top of the birdhouse to the ground x. And I was told that the mouse's hole is 20 feet from the pole that holds up the ground. So I labeled that 20. Since I'm working with this 25-degree angle right here, across from that will always be called the opposite. And the other leg in the right triangle is the adjacent. That's the side that's next to the angle. Since I'm working with opposite and adjacent, I know my mnemonic, SOHCAHTOA. So I have opposite and adjacent, so that tells me I have to use tangent. Tangent of the angle equals opposite over adjacent. When I substitute in, the tangent of 25 is equal to x over 20. To solve, I can multiply by 20 on both sides. I just want to make sure that my calculator is in degree mode. So when I have 20 times the tangent of 25 and I round my answer to the nearest tenth, I get 9.3 is equal to x. And then I check my units. It says that this distance right here is measured in feet, so my height will be measured in feet as well. So my answer is 9.3 feet. And another word problem example, we're told that a shark is swimming 25 feet under the surface. So to me, I draw a flat surface for the water, and I drop a perpendicular down from that surface to say that I'm 25 feet under the surface. And the shark over here is not directly under the surface, so I moved it off to the side, but that distance of 25 feet is going to be the same. It says that it sees a surfer 100 feet away. So that means that the distance from the shark to the surfer is 100 feet. The question asks, at what angle of elevation is the shark looking? Round your answer to the nearest thousandth. So remember, angles of elevation have to go from horizontal. So my shark's doing the looking, so I drew a horizontal from the shark to directly underneath the surfer so that I could get my angle right here, which I called x. Since I have a right triangle, I'm going to figure out which sides I'm working with. Opposite the angle is always opposite. Across from the right angle is always the hypotenuse. So in this problem, I'm using opposite and hypotenuse. If I remember SOHCAHTOA, the O and the H from so tell me to use sine. So the sine of the angle is equal to opposite over hypotenuse. When I substitute in, the sine of x is equal to 25, the opposite, over 100, the hypotenuse. I'll take the inverse sine of both sides to get x equals, and it says to round my answer to the nearest thousandth, so I'm going to write 14.478. Since it's an angle, I know that my unit has to be degrees. In this next problem, we're told that a person flying a kite lets out 75 feet of string. We should be aware that a kite typically flies diagonal from the person, so we should draw it so that it's our diagonal. And it says that the person ties the kite to the ground. So I have this drawn where my string is tied to the ground, my kite is up in the air. It says the kite's 50 feet above the ground, so I drop that perpendicular down to the ground. I have the ground drawn so that I have my horizontal. And we're asked to find the angle of elevation the kite string makes with the ground. So the angle of elevation will be that relationship between the diagonal segment and the ground segment, which we're calling x. I'm told the kite string's 75. I'm told that I'm 50 feet above the ground. So we have two sides of a right triangle. We're asked to find the angle. That should be a huge sign for all of us that we should be using trigonometry. The 50 feet is the opposite side, opposite the angle that we're using. The 75 is the hypotenuse, so we should choose to use sine. Remember, sine of an angle equals opposite over hypotenuse. When I substitute in, sine of x equals 50 over 75. I take the inverse sine of both sides to get x equals 41.81, because we were told to round to the nearest hundredth. And since it's an angle measure, we write that in degrees. In this problem, we were told that a 6-foot man stands on top of a 90-foot tower. So I drew that. I drew a man on top of a tower, and I realized that the 90 feet plus the 6 feet makes a total of 96 feet. And it says that he looks down at the ground and sees a woman, a 5-foot woman, 300 feet away. So I have my little stick figure woman down here. And I'm going to draw a point representing the top of the man to the top of the woman. We're asked to find the angle at which the man is looking. So when we find these angle measurements, remember, we're typically going to be finding an angle of elevation or depression. So we always want to draw that from a horizontal. So I have my man here, and I'm going to have his horizontal represented by the segment looking up to the right, and then since he's looking down, I draw this diagonal. The angle that I'm looking for is the angle that's formed between the horizontal and diagonal segment. I'm told that the distance between the man and the woman is 300 feet, and since I know that this whole side's 96, this whole side has to be 96. So since the woman's 5 feet tall, I know the segment that connects the top of the woman's head to the horizontal is 91 feet, because 96 minus 5 is 91. I have my 300 feet, which is opposite the right angle, so that's hypotenuse. I have my 91 feet, which is opposite the angle that we're finding, so that's called opposite. When we have opposite and hypotenuse, we should choose to use sine. Sine of an angle equals opposite over hypotenuse. So sine of x equals the opposite 91 over the hypotenuse 300. To solve, I take the inverse sine of both sides. And the directions didn't tell me to round, so I'm not allowed to round. I'm going to just copy exactly what's on my calculator. So x equals 17.657923131 degrees, because an angle measure is always measured in degrees. I have one more example for you. Feel free to rewatch these examples if you're struggling or if I'm going too quickly for you. In our last example, we're told that a sniper is on a hill. So I have my hill right here, and I have a point representing my sniper 1,000 yards from a target. So we're going to have our sniper looking down toward the target. because it says that he's looking down at an angle of 10 degrees. So remember, we're always working from that horizontal. So we have this horizontal segment. We have our sniper looking down at the target, and he's looking down at an angle of 10 degrees. Oh, actually, there's a pronoun her here, so it's actually a she. So we have our 10-degree angle. We have 1,000 yards. And the question asks, how much higher is the sniper than her target? Well, height is a change in vertical measurement. So I'm going to draw that vertical from the target up to the horizontal sight line to create my right angle. Since I'm working with a hypotenuse and an opposite again, yet again, this is another sine problem. Sine of the angle equals opposite over hypotenuse. In this case, our angle is 10 degrees, our opposite is x, and our hypotenuse is 1,000. When I substitute in, I'll have sine of 10 equals x over 1,000, multiplied by 1,000 on both sides. Put that in my calculator. Make sure you're in degree mode. Please remember that. And it doesn't tell me how to round, so I don't round. I write out the entire decimal. I get 173.6481777. And I want to match my units. So since the 1,000 is in yards, this measurement is in yards as well. These are just a few examples. I gave you 6 to try over the next 2 days, so feel free to refer back to these and look at those answer keys carefully when checking your own answers. Good luck.